But what if you wanted an even smarter material, one with a more varied response? To find stuff like that, we're better off out of the lab and at the movies. The T-1000 from Terminator 2 could have won an Oscar for Best Adapting Material, because this liquid guy can sense, respond, and even self-heal. It's the material itself that does things. He's a lifelike fluid that's very, very smart. Okay, that's science fiction. But in the search for smarter materials, engineers have taken a hard look at some liquids with very strange behaviors. They're called non-Newtonian fluids. I traveled to North Carolina to the Lord Corporation, which manufactures one. But when I arrive, I have a burning question for engineer Lynn Yanyo. Forget non-Newtonian. What's a Newtonian fluid? She offers to show me one.
This is a Newtonian fluid. Take a look at that.
Turns out, this Newtonian fluid is water. What makes it Newtonian? I've never thought of it as Newtonian before.
It makes it Newtonian because Isaac Newton discovered there was a relationship between how hard it is to move it and the viscosity.
Viscosity meaning thickness?
The thickness. Resistance to flow.
When you try to move something through water, the resistance is directly proportional to how fast you move it. Twice as fast is twice as hard. Now that's kind of what you'd expect. But amazingly, that's not true for lots of other fluids. The non-Newtonian ones. Like ketchup. Ever wonder why it's so hard to get it out of a glass bottle? That's because, unlike water, it thickens at rest, its molecules creating a weak structure that resists flowing. Yes, I remember this from my hamburger days. Ladies and gentlemen, it does not flow. Lynn is staking her scientific reputation and her hairdo on the non-flowingness of ketchup. But if you can get it started, that structure breaks down and the ketchup thins and flows. Here's another non-Newtonian fluid. In fact, a lot of it. Oh, here it comes. Definitely a liquid. This mixture of cornstarch and water is known as oobleck. Oobleck dramatically changes its viscosity, or thickness, depending on how fast you try to move it. Keep the action soft, and it flows like a liquid. But hit it hard, and it's solid enough that you can run across it. When I squeeze it tight, it turns into a rock, and then when I let go, it turns back into a liquid. What is happening?
We like to call this the Three Stooges effect.
That's not the scientific term. What do you mean the Three Stooges effect?
You know when the Three Stooges tried to get through the doorway and they couldn't?
Spread out.
The cornstarch doesn't want to get out of its own way. So when you push on it really hard, it can't move out of the way fast enough. And if you hit it really slowly, you can go right through it like a liquid.
So it's a liquid solid. You know, it depends on the pressure or the speed or something.
It depends on the speed at which you try to move anything through it.
Oobleck's a lot of fun. Be sure to fill your neighbor's pool with it. Oh, it's got me! But non-Newtonian fluids designed into the right system can save your life.
There go the lights.
Imagine a material that can adjust its thickness to absorb the seismic shakes of earthquakes.
The West Grand Freeway has come down. If we have a 50% section, we should collapse.
Or dampen the vibrations caused by wind that can pull a bridge apart. That's what the non-Newtonian fluid Lynn has in her hand can do.
So the interesting thing about this is that it's very responsive to a magnetic field. And it's a lot like oobleck. Take the spoon and scrape around in there.
Okay. Oh man, that is unbelievable. It's cement. It's...
So now scoop some of that up and just take it out of the magnetic field by lifting it up.
Oh, no way. This is like X-Men stuff. So it's a magnetic liquid.
Mm-hmm. We call this magnetorheological fluid.
You got a shorter nickname?
MR.
MR fluid? Can I call it Mr. Fluid?
No.
A typical MR fluid consists of tiny iron particles suspended in a fluid like oil. Without a magnetic field, the liquid flows freely. But add a magnetic field, and the metal particles line up. increasing the fluid's thickness. Lord puts that variable viscosity to work in devices like shock absorbers.
And then there's another suspension that's larger, and that's for really heavy-duty vehicles.
Heavy-duty vehicles like Humvees. For the military, a smooth ride isn't about luxury. How well a vehicle handles bumps determines how fast it can safely travel, as well as how fatigued its passengers become, both life and death issues on the battlefield. Out here in the woods, I'm going to see just what kind of a difference using a smart material can make in a Humvee's performance.
Good heavens.
Well, here you are. This is your ride. And for this first ride, we have this military Humvee, and it is just retrofitted with the conventional shocks that you would have when this was used out in the field.
A typical shock absorber is built around a piston filled with oil. When the piston moves down, it forces the oil from one chamber to another through small holes. The thickness of the oil and the size of the holes determine how much force that takes. If neither varies, the shock is a one-size-fits-all dampening solution, no matter how bumpy the road is.
How do you make this seat recline anyway? That was pretty bouncy. You should sell tickets to this thing.
For round 2, the Humvee gets the smart shock absorbers. They also use a piston design, but they add MR fluid full of iron particles and an electromagnet where the fluid flows through the holes. A computer controls the electromagnet in real time, varying the viscosity of the MR fluid. This system adjusts how much force is needed to move the piston in response to the bumpiness of the road. That makes the shock absorber tunable. It can react nearly instantaneously to different size vibrations. And that's very smart.
Ah, this is nothing. How do I adjust the AC? So, you're telling me that was the exact same speed?
Exact same speed.
Well, I can tell you, if I were a soldier, I'd vote for these shock absorbers.
Oh, yeah, you can see why that's a huge difference for those guys if they have to travel 25 miles in that, and the vehicles will last longer. Don't forget your seatbelt.
The abilities of smart fluids scale far beyond Humvees. Engineers see a big future for them in bridge construction to squelch vibrations caused by wind and bad weather. And even for use in buildings to counteract the awesome power of earthquakes, like a steadying hand. Sophisticated smart materials can react to outside forces to protect bridges and buildings, but they can be even more lifelike, allowing us to realize one of humanity's oldest dreams.